Welcome to 8F of our recursion unit, year 11s, and I hope you guys have been recapping or learning on the previous chapters as well. Before we get into this one, let me recap real quick what we learned about in 8E, where we examined geometric sequences. Okay, so we started geometric sequences. Remember that a sequence is basically a list of numbers, and they can either be broken down into being geometric or arithmetic, which are the two sequences we've been learning about. Arithmetic sequences involve, so I'll write that here. So arithmetic, remember, you're either adding or subtracting by the same amount. Okay, so you're either adding or subtracting. That amount can either be a decimal or a whole number. For arithmetic sequences, we also use what we call the common difference. Okay, and the common difference is basically that amount you're adding or subtracting by. And we use to find a common difference. Remember, it's any term minus the previous. Okay, and we also use, there's two rules that we use for arithmetic sequences. Okay, two main rules. So we have the nth term rule. Okay, which looks like this. So it's Tn, and this is to find any term. I'll put that here actually. Find any term. So if you're asked to find a term, use the nth term rule, and it's Tn equals A plus n take away 1 times d. Just remember what each value represents. A is the first term, n is the term you're looking for, and d is the common difference, which we can find there using that formula. And to generate a sequence, okay, we use bad spelling. Yes, that's correct. Sorry. Generate a sequence, we use the recurrence relation. And the recurrence relation for your arithmetic sequences, so these are different to geometrics. Your arithmetic, so you're adding or subtracting. Basically, you have to tell me what is the first term. Oh, actually, I'll write it like this. T1 equals A. So what's the first term? Okay, and then separated by a comma. And then this second part, you've got to tell me how to get the next term. So what's basically the common difference? Okay, so list out the first term and the common difference. Okay, so with geometric sequences, there are a set of also similar things from arithmetic, where you've got in arithmetic common difference and an nth term in a recurrence relation. There is also one for your geometric, okay, but it's slightly different. So instead of using common difference in geometric, so remember in arithmetic we used common difference. In geometric we use common ratio. And to find the common ratio, it's basically any term divided by the previous term. Let me write that down here. So for common ratio, okay, this is basically the number that you're multiplying by, okay? And it's the same number. And to calculate that, it's going to be any term divided by the previous term. Okay, so that's how we find the common ratio. And that's what we learned about in the previous chapter for 8E. Okay, and we also graphed them as well. I think most people are familiar with the graphing. Just make sure you are aware of the table of values are set out. Okay, so let's get into 8F. So for 8F, we're going to learn about finding the nth term rule. So like I mentioned before, with arithmetic sequences, we have an nth term rule. And the nth term rule is used to find any term. Okay, any term. Basically, in the questions that we give you, it'll be a high value term. So it could be like term 100, term 50, term 30. Okay, and that's when we use the nth term rule. Okay, different to a recurrence relation. Recurrence relation, we use that to generate a sequence, but the nth term rule we use to find a really high value term. So for a geometric sequence, this is the nth term rule for it. I'm going to rewrite this so we can see it clearly, but I would also like you to write this down in the second page of your booklets as a formula and when to use it. So the formula is Tn equals A times R to the power of, and take away 1. Now, this is not times, it's to the power of. Okay, just make sure you understand that. It's the power of. And on your calculator, the power of button, it's basically, it's the, I think it's got a square with an arrow pointing upwards like that. That's the power button. Okay, so that's the nth term rule for a geometric sequence. Now, when do we use this? So use to find any term from geometric sequence, or for geometric sequence. Okay, so if you want to write down a definition of when you should use this, you can copy this down. Okay, so use to find any term for geometric sequences. And also you can see that in our geometric nth term rule that it's also got values A, R, and N, kind of like how in the nth term rule for an arithmetic sequence. Okay, remember it's very similar how you've got A, N, and D, but instead of using D, okay, in our nth term rule where we use D for arithmetic, for geometric we're changing D to R, and it's a slightly different variation of the formula. So R, remember, is the common ratio, and we use that for geometric sequences. And you'll remember in the previous lesson, okay, or if you look back at the previous notes, how to find the common ratio. N is the same, so it's the term we're looking for, and A is the same, so the term, which term we are after. Just keep in mind this is for geometric sequences. Okay, so here is a question that we can try. Find the 15th term or 15th number in this geometric sequence. So it already tells you that it's geometric. Here we need to figure out what A, R, and N are. It's a funny way of saying it, A, R, and N, because we're going to use our nth term rule for geometrics. So remember A, we need to figure out. We need to know, and what is N. So if you look at the, again, the definition for each letter, A is term number 1, or the first term. So if you look at your sequence here, you can label it if you want to. So T1, T2, T3, T4. I can see that T1, first term is 3. Okay. Next, common ratio. So to find a common ratio, remember it's any term divided by the previous term. So I'll put that here. Actually, I put it here, sorry. Any term divided by the previous. Okay. And I can use any of these terms because I know it's already geometric. It tells me there. I might go T2 divided by T1. All right, let's keep it simple. So that's going to be 6 divided by 3, which means the ratio is 2. So the common ratio, or the number you're multiplying by, is 2. And N, remember, is the term number we're looking for, and it tells me in the question that the term number is 15. So with my formula of Tn, which is my nth term rule, times R to the power of N minus 1, I'm looking for the 15th term. So the 15th number is equal to, okay, first term is 3 times the ratio of 2 to the power of 15. Just make sure that you understand it's to the power of and not multiplied by. Okay, I'll do that on this calculator quickly because my CAS hasn't loaded, but if I put that in my calculator, I can kind of see that. So it's going to be 3 times 2 to the power of, this button here, 15 minus 1. You don't necessarily have to put it in brackets, but it is good practice too, just in case. Okay, it gets a bit crazy. So there, put it in your calculator. The 15th number is 49152. So T15 is 49152. All Pretty straightforward. I think in order to use the nth term rule, just make sure you understand what the values that you need are. So what's A, what is R, and what is N? And you can find A just looking at the sequence. What's the first term? R is the common ratio, so use the ratio rule, which is any term divided by previous. There's the calculator. I'll leave that here for now. And N is the term number you're looking for, the term value, which normally is stated in the question. Okay, now this is where it gets a little bit tricky because we've been looking at common ratios, like basic common ratios. But for this part of the lesson, we're going to now examine percentage changes. Okay, so when something adjusts based on a percentage, or when something increases or decreases based on a percentage. Okay, these are two more rules that you need to now include in your second page of your notes. Okay, so use these formulas, okay, for when you have percentage change. So before I get into that, so when you have a percentage change, remember it could be like when you go to the shops and it tells you like something is like 50% off. Okay, that's a percentage change. Or when something increases by a certain percentage, that's also a percentage change. Like, for example, I'm going to increase my revenue by 2% each year. So that means each year, something is increasing by 2%, and then in the next year, that increases by 2% of the previous year. Okay, so it sounds a bit complicated, but I think once we do some examples, you'll get it. So the two rules you need to know, and I'll rewrite these here. So you have common ratio, which we know, remember, looks like this. Okay, any term divided by previous term. But this is for your common ratio when you're given a sequence like this. Okay, but if you're asked to find the common ratio when you don't have a sequence and it's a percentage change, we use this. Okay, these two rules. Common ratio, so I'll write that here. You don't have to necessarily write this in the second page of your notes, but just at least this part, but the next part you will. So common ratio for percentage increase or decrease. Okay, so understand that this part here that I'm writing down now is common ratio for percentage increase or decrease. Really important that you understand this, guys. So make sure you write this part, I guess. This next part here. Okay, these two rules that you need to use for your common ratios when it's a percentage change. Okay, so when your percentage is increasing, okay, we use this rule, R equals 1 plus the ratio, or I would say here the percentage over 100. Okay, so if something is increasing, okay, we use this rule here. R equals 1 plus the percentage over 100. So if your ratio is increasing, okay, so if you're asked to find the ratio for percentage increase, so you have to read the question to understand whether the sequence is increasing or decreasing. We use this. Okay, so you can see that it's that plus, okay, means it's increasing. Okay. But when a ratio is decreasing, so if you're reading the question, it tells you that something is decreasing, it's going to be 1 minus the percentage over 100. So you can see that it's a minus, so that means it's decreasing. So it's a ratio for percentage decrease. Actually, I'll write that here so it's a bit more obvious. Same with this one. Okay, so put this section here in the second page of your formulas, of your booklets. Okay, so this is the common ratio for when you have percentage increase or decrease. So you have to read the question. If it involves percentage increase or decrease and it hasn't given you the sequence, then we use these formulas to find the ratio, and this is for increasing. You can see that it's plus. So you'll notice that if a common ratio is greater than 1, okay, because it's 1 plus the percentage, it's going to increase. But if your common ratio is less than 1, and we mentioned this before, these two factors, it's going to decrease. See how it's 1 minus? So that means it's going to be a decimal less than 1. But see how this is 1 plus? It's going to be a decimal greater than 1, so it's increasing. Okay, let's put some of this to practice. So state correct two decimals the first 4 terms in each of these geometric sequences. Okay, so we have to figure out what are the first 4 numbers in these geometric sequences. So just understand, okay, that when it says it starts at 200, okay, that doesn't mean that that's the first term. Okay, it just means it starts there. So we've got to list the next 4 numbers. Okay, from there. So this starts there, starts at 200, and each new term is 4% less than the previous. Okay, so reading this, I can see that I have this term here, and based on what this is saying here, it's 4% less. So the common ratio, 4% less, means that if I want to find the common ratio, I'm going to use the decrease, because it's 4% less, so it's going to go down. So to find the common ratio, i.e. the number that I'm multiplying by to decrease, or to get the next term, okay, I have to use the common ratio there, this one here. Okay, let me change color here real quick so I'm getting confused. So let's do that for part A. Okay, starts at 200, each new term is 4% less than the previous term. So for the common ratio of this, I know, okay, that the percentage is going to be decreasing. So I use my decreasing formula there. I'll write it down here for you. So it's going to be 1 take away the percentage over 100. Okay, and that's going to be 1 take away the percentage of 4 take away 100, and that will equal, if Toddy's got his maths correct, 0.96. Okay, and you can put that in your calculator if you want to double check. So it's going to be 1 take away 4 divided by 100. If you can press Control Enter to get the decimal, there you go. Okay, 0.96. So that means to get the next term, we're multiplying by 0.96. So I'm going to write here T0 for the starting term, which is 200, but we need to write down the next 4 terms. Okay, because now the reason why I've written 200 as T0 is because 200 is not the first term. Okay, it's the starting term. Okay, it's where we start. All right, so just understand that. So that means to get the next term, we're going to multiply by 0.96, and then we're going to repeat that process to get to the end. Now, in terms of working this out, there is a proper way of showing it, and you'll remember back in the previous chapters where we went T1 is equal to, and whatever the formula was for the nth term rule. Okay, but for now, I think we can use that calculator for this, okay, because it doesn't actually say to show full working out for now, but later on, when we use the recurrence relation, you will need to show your full working out. So for now, we can just use a calculator. Oops, I opened the wrong one. So let's go delete all of these ones. So the first term is, as we know, 200. Okay, looking at my sequence here, yep, 200. Okay, cool. So to get the next term, you're multiplying by 0.96. Remember, our common ratio is 0.96. So to do this, write down your starting term, press enter, and now you're going to multiply by 0.96. So if you keep pressing enter, there's term 1, term 2, term 3, term 4. Okay, so let's write all that down. Term 1 was 192. Then term 2 was 184. 4, I might need to zoom in, sorry peeps. So term 2, that's fine, was 184.32. Term 3 was 176.9. We'll just round these to 2 decimals. 176.95. Oops. Keep in mind, I will need to make more space for this next time. And then let's make that more clear. Term number 4 was 169.87. So notice again how, because you're multiplying with a number less than 1, okay, see how the values tend to decrease. Okay, all right, part B, probably similar thing, but instead of decreasing, it's going to be increasing. Okay, so we're going to repeat the process, but instead of decrease, we're going to increase. So read the question again. Starts at 500, so that's my starting term, and it's going to be 12% more. So this time it's increasing. So instead of using the minus because it's decreasing, for the previous one, this time we're going to use the increasing common ratio. Okay, to find the ratio for this, it's going to be 1 plus. And according to this, it's 12% more. Okay, see that? 12% more. Look out for the words to tell you whether it's increasing or decreasing. 12 over 100. That means the ratio is 1.12. And notice how, again, the ratio is going to be greater than 1. So these terms are going to be increasing. Give myself more space this time. Okay, so my starting term is 500, and each new term after that. Okay, now this is just for these questions. Yeah, there'll be a proper way of showing the working out to get these terms later on, and you'll probably all be familiar with it as if you've watched the previous lessons. Okay, so you can see that it's going to be multiplying by 1.12. So putting that in my calculator, we start at 500. Actually, let me get rid of this so it's clear for you guys. So 500. Okay, start with the starting term, then press enter, and then you're going to multiply by the ratio of 1.12, which we calculated here. Okay, it's an increasing, so you can now guess what's going to happen. It's going to go up. So this is term 1, term 2, term 3, term 4. And we'll just round these answers to 2 decimals. So term 1 is 560. Term 2, 627.2. Yep, 627.2. Term 3, 702.46. And the last term, term 4, 786.76. Okay, so that's how we generate this sequence just based on this question here. Let's move on. Oh, okay, I've already done that. You can just leave that. Okay, application questions. And then I think after that we can start the chapter work. So application questions here. So we're going to use what we've learned previously to now figure out these questions. So as a park ranger, Megan has been working in a project to increase, okay? Here's a key word there, increase the number of rare native orchids in Wilson's Prom. At the start of the project, keyword there again, okay, the survey found that there were 200 orchids in a park. So at the start, there were 200. It is assumed from similar projects that the number of orchids will increase, another keyword there, by 18% per year. Okay, it's going to increase by 18% per year. Part A, state the first term and common ratio for this geometric sequence. Okay, so part A. Actually, let's read through the questions. Part B, find the rule for the number of orchids at the start of the nth year. So find a rule. This one's a little bit tricky, but we'll get into that a little bit later on with the rule. And then how many orchids are predicted in 10 years' time. Okay. All right, so this one here, I think I'm going to try and explain it in a way where people hopefully do not get confused, because this rule bit might trip some people up, depending again on what we treat for the first term or the starting term. Okay, so state the first, let's do part A, state the first term at least, A and the common ratio. Ooh, actually, I think I made a bit of a mistake. Hopefully people don't get confused, but the way that this is worded, and maybe this is a fault on the textbook, it does say start. So normally this you should treat as T0, but I believe based on the question here, we're going to treat this as A, as the first term. Okay, so as to not to confuse people, we're going to treat this as the first term. Okay. Hopefully you don't get confused with that, but just for this question, okay, we're going to treat this as the first term. So for this question, I can see that we need to figure out what is term A, first term, and the common ratio. So for this first term A, just reading the question, I can see that the first term is 200. Okay, and then for the common ratio, this is a percentage increase. Okay, so orchids will increase by 18% per year. Okay, so that means we're going to use the R equals 1 plus the percentage over 100 rule. So I know that the percentage is 18, so 18 over 100. Therefore, the R value is 1.18. That's the first part. Okay, 1.18. Okay, part B. Now the rule bit, I'm hoping again, there's actually space here. So part B, find the rule for the number of orchids at the start of nth year. Okay, now in terms of the rule, we're going to just use the nth term rule that we learned at the start of this chapter. HE. So this is the nth term rule that we will use, and the format will look like this. Tn equals A times R to the power of n minus 1. Okay, so for this part here, we're going to now use the rule. Remember that the rule looks like this. Tn equals, for part B, A times R to the power of n minus 1. So basically on my rule, I just need to, it's already stated it there, doesn't it? Oh no, sorry, I'm looking at the wrong one. Sorry guys. Oops. Right here. Part B. Tn equals A times R to the power of n minus 1. So we're looking at this question. Sorry, that's very confusing. Alright, part B is find the rule. So we're going to use this rule for part B. Now the rule, remember, you need to figure out what is the first term, which we already know, and what is the common ratio. So here we have the first term and we have the common ratio. So the general rule to find the number of orchids at the start of nth year is going to be Tn equals A, so the first term of 200, times R, common ratio of 1.18, so 1.18 to the power of n minus 1. So if I ask you to find any term for whatever term at the start of nth year, then we would use this rule. And then part C is now use that rule to find the number of orchids in 10 years. So T10, looking at the rule, Tn equals 200 times 1.18 to the power of n minus 1. And I'm looking for term number 10, so T10. T10 equals 200 times 1.18 to the power of 10, take away 1. Okay, so putting that in my calculator, 200 multiplied by 1.18, and then the power button is this, to the power of 10 take away 1. And that means on the 10th year we'll have 887 orchids. So T10, 887 orchids. Okay, now I hope that's all made sense. If you want to rewatch the video again to understand some of the certain parts for this, but main thing to watch out for is, I think for now, just use this nth term rule, okay, and you look at the example that's given to you here to actually figure out how to find any term that you're after. Okay, so for now, I think maybe we'll disregard using T0, okay, because it is a little bit confusing. Okay, but because it's a starting term, and it does say here, and the way that I think the way that the textbook is set out, it sets it out so that it should use in this part of the question the first term. Okay, so you want to just use this rule, okay, for this chapter. Okay, but we'll get into using T0 another time in next chapters. But go ahead and start your exercises for 8F. Remember, by the way, I should point out, use the checklist at the front of your textbook, please, or front of your booklet. Thank you.